Hey guys, welcome back. Alright, in this lesson I'm going to be discussing identifying functions, okay? Now, when I looked at you guys' mock star, quite a few of us missed questions over functions and we really should not have missed those. So let's go ahead and start this week off with a simple task, identifying functions. By definition, a function is a relation in which each input, that is the x, is paired with exactly one output, that's the y. That second definition says a function is a relation in which each element of the domain is paired with exactly one element of the range. Things that I need you to pay attention to is right here where it says exactly one output, exactly one range. One element of the range, exactly one y. So on these tests, when you see that exactly one, that one correlates with the y variable and the output and the range, okay? Now I need to make sure that that's clear, because the definition comes out quite a bit tricky. Because when I taught you functions, remember I taught you, hey, functions, you can't repeat x's. That's true. But when you see this definition, make sure you look for the definition that says exactly one output, exactly one y. Now, let's take a look at the four ways that we talk about functions. The first one is what we call ordered pairs. Now, ordered pairs are simple, okay? You have the x and then you have the y, okay? Look at the example that says this is a function. Remember, I said you cannot have repeating x values. So in this example, we have -2, 0, 5, and 8. There are no repeating x's. That's a function. Let's look at this next example. You have -3, 0, and then you have 2 and 2. This relation is not a function because there are two 2's in the domain, which is the x, the input. Okay, so let's pause for a second, all right? I'm going to go to the whiteboard behind us, all right? Now, on the whiteboard, I have 3 examples. What I want you to do is I want you to pause the video for just a brief second, and I want you to identify, hey, which one of these is a function, which one is not a function. Let's take a moment, and let's look at this. All right, you should have paused the video. Now let's look at number 1. Is number 1 a function? Yes, it is. If you look at the domain, you have 2, 3, 4, and 5. Okay? 2, 3, 4, and 5. There are, by definition, no repeating x variables there. Let's take a look at number 2. Is 2 a function? No, 2 is not a function. Why? Why is 2 not a function? Well, if you look at it, we have 2, 6, 3, 2. You have 2 2's. The 2 2's make this not a function. Quite different than example 1. You have 2 7's, but remember, that's in the y coordinate. That's in the y-axis. That's in the y spot. We don't care about the y's. We're only looking at the x variable, the domain, the input. Okay? Let's look at example 3. Is example 3 a function? Yes, it is. You have 3, 5, -5, and -3. 3 and -3 are not the same number. That's the same thing as, or that's kind of like saying, would you rather owe somebody $3 or would you rather somebody owe you $3? That's the difference between +3 and -3. They're not the same. And the same with 5 and -5. Would you rather owe somebody $5 or would you rather somebody owe you $5? That's the same concept that applies here. Okay? So number 3 is a function. All right? Let's move on to our next topic, or our next one. The next function representation, and we have tables. Tables are actually fairly simple. It's just like ordered pairs. You identify the x, you identify the input, and you identify, hey, are there any repeating values in the x coordinates? So we're looking here, we have -4, 0, 4, and 8. Well, we just said that. -4 and 4 are 2 different numbers. Therefore, this is a function because there are no repeating x values. Let's take a look at the non-function. And you see it there, you have 2 2's. That should be simple enough. Let's move on to the next example. This is what we call maps. Okay. Now maps, a lot of students like to look at maps and just be like, oh yeah, that's not a function. No, that is not what I taught you. That's not how I instructed you. My instructions were to take the map and make the maps ordered pairs. Okay, so I'm going to make these ordered pairs, and then I'm going to enlarge the screen so that we can take a look at this and make sure that we're correctly interpreting this information. All right, here we go. So we have 7. 7 goes with 12. 7, 12. We have 5 and 20. We have 3 and 2. And then that last one, we have -4 and 20. -4, 20. And then I'm going to put this other example on the board, which is -7. And that goes with -7. This next one, we have -7 and 7. Then you have -4, -1. And then the final example, you have -1, 0. Alright, so let's go ahead and enlarge the screen, and then let's take a look at these two. Now remember, my directions is, hey, make them ordered pairs. Let's not get lazy. Let's do the work. It's very simple to take these and make these ordered pairs. Don't be lazy. So looking at this, you have 7, 5, 3, -4. You can easily see now and identify, oh, that is a function. There are no repeating values. You don't have to squint and try to figure out which line is going where. You don't have to do that if you follow my directions. You don't miss it. Let's go to this one. We have -7, -7, -7, and 7. This is not a function, ladies and gentlemen, boys and girls. We got two -7s. We can have a functional relationship. It's two x's. Okay? Let's take a look at our next example. Make sure my board don't fall. It's leaning. Alright, let's look at this next example. Alright, the next example. Take a moment and assess whether these are functions or not. You should have paused the screen. I'm trusting that you paused. Work those out. Alright, A. Is A a function? Yes, it is. If you wrote out your ordered pairs, you would see that B goes with Q, C goes with Q. There are no repeating x's. Looking at the second one, I'm sorry, B. Is B a function? B is not a function. If you wrote out your ordered pairs, you will see that A is paired with Q and A is paired with R. That disqualifies it from being a function. C is a function and D is a function. Let's go to our final one. Our final example is what you call graphs. How do you determine if a graph is a function? Mr. George, I don't see any x's. Well, I'm glad you said that. The way that you determine if a graph is a function or not is by the vertical line test, not the horizontal line test, the vertical line test. Let's go to the board and I'm going to demonstrate what this vertical line means, okay? Well, there we go. All right, so vertical line test says that if you draw a vertical line directly through your relation, it should only cross one time. Okay, so I'm gonna draw a couple of these on here. Let's do something like this. Let's do a little squiggly. Let's do a upside down parabola. Let's do the letter S. Let's do a base clef sign. All right, and let's do something like that. All right, the vertical line test. If I draw a vertical line through this, how many times did I cross? Once. At any point I draw a vertical line through this, no matter where I draw my vertical line, it only intersects one time. That's the vertical line test. Let's look at the base clef sign for an example. If I draw a vertical line through my base clef, Now, I can say, let's extend this. I can draw it over here and be like, oh, I only intersect once. That's true. However, if you draw your line here, you intersect twice, disqualifying this from being a function. The letter S, I cross more than one time. That's not a function. Upside down parabola, parabola. I'm having trouble saying that, parabola. But anyways, no matter where I draw my vertical line, I only intersect one time. The same with my little, I'm going to call this the stock market. Hopefully that thing bounces back really soon. I only cross one time. Uh-oh, you guys can't see that. My chair's in the way. It only intersects one time. Okay? So remember, the vertical line test is how you determine if a graph is a function or not. Okay? So, let's get back in here. Let's come back to this. Alright. So looking at these two examples, you can see that this only intersects once. And if you look at this example, it intersects twice. Therefore, it is not a function. Guys, functions are extremely, extremely easy. This video went longer than what I really wanted to. I try to keep these videos really short, sweet, simple, and to the point. But guys, this is very, very, very simple information. Alright, so check this out. Work on some of the practice problems. If you guys have issues, you can contact me or any of your other instructors, and we can set up tutoring during our office hours. Alright guys, have fun. Peace.